Hello, welcome to another of my new video. In today's video, I'm gonna be talking something pretty interesting. It's known as a variable capacitor. Especially this is a Dural gang. Now, this sort of things is really hard to find in the modern electronics. As previously as shown you, I made a high frequency solid state Tesla coil producing the plasma flame. I have to use a very cheap homemade aluminium foil with some polyethylene bag variable capacitor. Well, it did work, but it does not work great since the dielectric loss is pretty high and cause the foil to heat up quite considerably, and meltdown and breakdown causes the arcing between the plates, and this finally killed my MOSFET. So therefore, these things I'm gonna show you here is actually a high quality made variable capacitor in the olden days. The things about the variable capacitor is that it uses air instead of using other dielectrics such as polyethylene. It's really rare to find any good dielectrics now, because for example polyethylene, it has a really high loss during the high frequency stage, but Teflon works great. Best things to use I guess would be ceramic, but usually you will be using air, or one of the best things as well would be vacuum. Vacuum is really expensive, where usually no people can afford it. It can't be low vacuum or else itself become pretty conductive, so it has to be using high vacuum. Whereas here we're using is air. Air find is really plentiful around us, and it has a really high dielectric constant, can withstand a pretty high voltage. And from the gap I look here, it's about like a 0.8 millimeters gap, so it can hold about 800 volts before it breaks down. So I will just rate each capacitor as 500 volts. If I need 1000 volts, I will have to link two of them together and perhaps lift them up with some insulators to prevent them taking out the ground effect. Tuning them, you will have to use something with plastic. But anyway, to showing you that variable capacitor like this one is made quite pretty high quality. The insulators has been mounted with stiff plastics, so the stator, as you see here, does not move. Stayed stationary even during heavy vibrations like knock-ins, and it's being held by a screw for the rotor shaft, and with bearings, which I also put a little bit of Vaseline oil. Make sure you do not put on the plate, so therefore you would not destroy the plate. As for its insulations, the plate is usually being polished and being applied with silver, so you would not want to destroy the silver plating layers. And silver can turn dark really quickly due to the formation of silver oxide and silver sulfide. Oxide is really rare to see, but mainly forming the sulfide. And here's the nickel strip for earthing. But anyway, the terminals we can connect either side, and the plate is being all held by an insulator strip, so make sure we don't overturn. And the entire thing for the knob is also made of brass, so this shows it's a quite high quality variable capacitor. And variable capacitor like this one will be using an actual tune radio equipment, so therefore when it's tuning, it requires high stabilities with two vanes of the two tuning coils to get a really specific resonance frequency. As if I lift up the plate a little bit more, you can see there's a cut between the first and the final plate of each section cell of the variable capacitor. The reason for their cut is you can bend the plate or push it around to give the desired frequency on your tune meters, as this will also be attached to a meters or a dial, so you know the exact frequency you'll be tuning around into. And that's it. This is a really simple video about variable capacitor, and thanks for watching. Be sure anyways to stay safe.